Deep beneath our feet, the Earth is alive with activity. Millions of years of geological processes have formed volcanoes, but some remain hidden, waiting for the right moment to reveal their destructive power. Among these, supervolcanoes are the most terrifying. These colossal geological formations can erupt with an explosive force thousands of times greater than a regular volcano. Imagine a single eruption that could blanket continents in ash, disrupt weather patterns, and lead to a volcanic winter lasting years. Supervolcanoes such as Yellowstone in the United States, Toba in Indonesia, and Campi Flegrei in Italy hold this power. Yellowstone, which straddles the states of Wyoming, Montana, and Idaho, lies over a massive magma chamber believed to be about 30 miles wide. This volcanic system has erupted several times in the past, with its most recent eruption occurring approximately 640,000 years ago. The ash from this event spread as far as the east coast of North America. Some scientists estimate that if it were to erupt again, it could unleash devastating consequences worldwide. Historical eruptions give us insight into the catastrophic potential of supervolcanoes. The Toba eruption around 74,000 years ago is one such event. This eruption is thought to have caused a volcanic winter that led to a dramatic drop in global temperatures, possibly contributing to a bottleneck in human evolution. Genetic evidence shows a significant reduction in human population at that time, suggesting that the eruption may have played a pivotal role in shaping humanity. Furthermore, scientists have studied the ash deposits from the Toba eruption, finding that it spread as far as Africa and Europe. The effects of this eruption were felt for thousands of miles away, demonstrating just how interconnected our planet's climate systems are. As temperatures dropped, vegetation was destroyed, and it's believed that many species faced extinction. But what exactly would happen if one of these supervolcanoes erupted today? The answer is unsettling. Modern society, with its dense populations and reliance on global supply chains, is uniquely vulnerable. An eruption could lead to widespread crop failures, food shortages, and economic collapse. As we delve deeper into the world of supervolcanoes, we'll explore their geological formations, historical impacts, and the monitoring efforts aimed at predicting their potential eruptions. Each layer of the Earth contains secrets, and these ancient giants hold the keys to our planet's past, and possibly its future. As we embark on our journey to understand the ticking time bombs that are supervolcanoes, we turn our attention to Campi Flegrei, located near Naples, Italy. This complex caldera is one of the largest and most dangerous volcanic systems in the world. It last erupted in 1538 but has been showing signs of unrest in recent years. With its densely populated surroundings, an eruption here could have catastrophic consequences for millions of people. Campi Flegrei's potential to erupt is a pressing concern for scientists. In 2012, researchers detected increased seismic activity and ground deformation, signs that magma is moving beneath the surface. Such changes can indicate an impending eruption, but predicting the exact timing and scale remains a challenge. If history teaches us anything, it is that the eruption of Campi Flegrei could rival, if not exceed, the scale of the infamous eruption of Mount Vesuvius in 79 AD, which buried the Roman cities of Pompeii and Herculaneum. The legacy of Vesuvius serves as a stark reminder of the destructive power of volcanoes. In 1969, a dramatic increase in seismic activity led authorities to evacuate around 40,000 residents from the surrounding areas. This precaution was one of the largest evacuations in European history, showing the potential for mass panic and dislocation in the event of an eruption. Campi Flegrei is not only a geological wonder, it's a psychological one too, as it forces us to confront the fragility of our civilization. Researchers continue to monitor Campi Flegrei, but its complexity poses significant challenges. Unlike traditional volcanoes, it exhibits eruptions of varying scales, and the eruption dynamics can be influenced by a myriad of factors, including geothermal activity and magma composition. Recent studies indicate that the caldera's center is gradually sinking, raising concerns about the possibility of explosive eruptions as pressure builds. These challenges highlight the uncertainty surrounding supervolcanoes. No two eruptions are alike, and predicting their occurrence involves a game of geological roulette. The delicate balance of nature is evident in supervolcanoes like Campi Flegrei, which remain largely unseen, their power lying dormant yet ever-present beneath our civilization. As we explore these volcanic giants further, we must confront both the awe and fear they inspire. How do we reconcile nature's unpredictability with our human desire for control? To truly understand the catastrophic potential of supervolcanoes, we must examine the most devastating eruptions in history. One of the most significant was the eruption of Mount Tambora in Indonesia in 1815. This eruption is often considered the most powerful in recorded history and led to the infamous year without a summer in 1816. The explosion ejected an estimated 160 cubic kilometers of volcanic ash into the atmosphere, resulting in global climate anomalies. The consequences were severe. In the United States and Europe, temperatures plummeted, leading to widespread crop failures. In New England, snow fell in June, and summer frosts destroyed what little food was available. People faced famine, diseases spread as malnutrition took hold, and the social fabric of society unraveled. This disaster triggered migrations as farmers sought more hospitable lands, leading to an exodus from the Northeast. The eruption's aftermath demonstrates how interconnected our climate systems are and reminds us of the fragility of food security. In a world increasingly reliant on agriculture, the repercussions of a major volcanic eruption could be magnified by our global supply chains. A single eruption can show how nature retains the power to reshape human society profoundly. We must also look back at the ancient eruption of the La Garita caldera, which erupted over 28 million years ago. This eruption is estimated to have released nearly 5,000 cubic kilometers of material, making it one of the largest eruptions in Earth's history. Its impact on global climates and ecosystems was profound, potentially leading to a mass extinction event. The ash from this eruption would have blocked sunlight, causing a dramatic cooling period that altered biomes and led to the extinction of various species. The La Garita eruption is a stark reminder of the Earth's capacity for destruction. It raises questions about our geological past and what it might portend for our future. With each major eruption, we see a pattern of destruction following by renewal, but often at an unimaginable cost to life. These historical lessons are critical as we look to the modern world. Understanding the impact of past eruptions enables us to grasp the potential consequences lurking beneath the Earth's surface today. If a supervolcano were to erupt in a densely populated area, the result could be catastrophic beyond comprehension. How will society respond to such a calamity, and what measures are in place to safeguard humanity? Predicting volcanic eruptions remains one of the most challenging aspects of geology. Scientists employ a variety of methods to monitor volcanic activity, from satellite imagery to seismic sensors. The goal is to understand what happens beneath the surface as magma moves toward eruption. One of the most crucial methods includes analyzing ground deformation. When the ground begins to swell, it indicates that magma is accumulating. At Yellowstone, for instance, researchers closely monitor ground deformation using GPS and InSAR technology, which can detect changes in the Earth's surface down to millimeters. These measurements play a critical role in forecasting potential eruptions, but they require constant vigilance. In addition to ground deformation, scientists also analyze the gases emitted by volcanoes. Changes in the composition of volcanic gases can signal that magma is rising. Sulfur dioxide, for example, can indicate impending volcanic activity. By measuring gas emissions and monitoring seismic activity, researchers can obtain clues about an eruption. However, predictions are inherently uncertain. By studying previous eruptions, scientists can identify patterns. However, no two volcanoes behave the same way. The unpredictability of eruption events adds to the challenge of communicating risks to the public. It is essential for authorities to have plans in place for evacuating communities surrounding potential eruption sites. For example, both Yellowstone and Campi Flegrei have emergency response protocols, but in the event of an actual eruption, the effectiveness of these plans would be tested. As scientists continue to explore innovative technologies for eruption prediction, such as machine learning algorithms to analyze vast datasets, the future holds promise. Determining when and where eruptions will occur may one day be more precise, but we must remain cautious, as the Earth has surprises in store for us. Additionally, public awareness and education play significant roles in preparedness. Communities residing near volcanoes need to be informed about the risks associated with living close to these natural giants. The more prepared people are, the better they can respond to the potential dangers. As we explore the rapidly evolving science of volcanic eruption prediction, we must consider the broader implications for society. How will we adapt to living in the shadow of these colossal forces of nature? While the immediate effects of a volcanic eruption can be catastrophic for nearby communities, the global impact can be just as profound. When a supervolcano erupts, the ash and gas released into the atmosphere can have far-reaching consequences. Volcanic ash can travel thousands of miles and find its way into the stratosphere, affecting global climate patterns. Historical eruptions, such as the 1815 eruption of Mount Tambora, showcase how interconnected our climate systems are. After the Mount Tambora eruption, global temperatures dropped by as much as 3 degrees Celsius, leading to disastrous agricultural conditions worldwide. This cooling contributed to significant food shortages, unrest, and even migrations. The eruption's impact demonstrated how a localized event could rip through the fabric of global interconnectedness. A modern eruption of a supervolcano could trigger similar or even worse outcomes due to our current global dependence on agriculture and trade. Beyond agriculture, an eruption could impact various sectors including aviation. Ash clouds can disrupt air travel, grounding airplanes, and leading to economic losses on a global scale. For instance, the 2010 eruption of Eyjafjallajökull in Iceland halted flights across Europe, affecting millions of passengers and costing the airline industry an estimated $1.7 billion. The disruption was a small-scale glimpse of how a supervolcano's eruption could send shockwaves through the global economy. The fallout from an eruption goes beyond economics; it can destabilize nations. In countries already facing challenges, a volcanic eruption could exacerbate existing tensions and contribute to conflict. With food and resources becoming scarce, social unrest becomes a likely scenario. History has shown us that environmental stressors can lead to political turmoil, and a supervolcano's eruption could serve as a catalyst. As we analyze the potential global impacts, the urgency for preparedness cannot be overstated. Communities near supervolcanoes must have evacuation plans and resources in place. At the same time, we must consider how nations can work together to mitigate the effects of a global disaster. As we continue to explore the implications of living alongside supervolcanoes, we must reflect on our resilience as a society. How can we prepare for a future where the potential for civilization-ending eruptions exists, and what steps must we take today to secure tomorrow? When we think of volcanoes, we often picture distant mountains spewing lava and ash. However, for millions of people around the world, volcanoes are an everyday reality, often residing just miles from their homes. Today, we explore the lives of those who dwell in the shadow of these titanic structures, communities that face the constant threat of catastrophic eruptions. In Indonesia, for instance, the island of Java is home to over 140 million residents, many of whom live near active volcanic sites. The most notorious is Mount Merapi, which stands as one of the most active volcanoes in the world. The last major eruption occurred in 2010, leading to the evacuation of over 350,000 people. The destruction was staggering. Lahars, or volcanic mudflows, obliterated homes, and ashfall contaminated water supplies, leading to humanitarian crises. Yet, despite the risks, many people choose to live near these volcanoes. The reasons are complex. For some, the land is fertile due to the minerals deposited by previous eruptions, making it ideal for agriculture. For others, cultural and historical ties to the land run deep. Communities often regard their nearby volcano as sacred. This paradox raises an unsettling question: how do we balance the undeniable beauty and bounty of these landscapes with the imminent danger they pose? The toll of living at the mercy of nature also extends to mental health. A study published in 2018 highlighted the psychological stress faced by those living near active volcanoes, revealing that the constant threat of eruption leads to anxiety, depression, and a phenomenon known as volcanic anxiety disorder. Imagine having to prepare for an event that could wipe away everything you know, all while trying to maintain the rhythms of daily life. The Philippines provides another sobering example. Mount Pinatubo's eruption in 1991 is one of the largest of the 20th century, creating massive ash fallout that affected air travel worldwide. The eruption displaced thousands and caused significant loss of life. But even after such devastation, communities rebuilt, often choosing to settle in the same areas, risking another eruption. The bond between the land and its people is profound. How can we measure the value of home, even in the face of danger? As we explore the concept of risk, we cannot ignore the role of government and disaster management agencies. Their task becomes both complex and critical: to protect lives while respecting cultural ties and economic realities. They implement strategies like early warning systems and evacuation plans, but often face challenges in communication and cooperation with local communities. Effectively passing along information can mean the difference between life and death. Miscommunication can lead to panic or apathy, both dangerous reactions in the face of a volcanic emergency. Now, let's shift our focus to the scientific community's role in monitoring and studying these threats. Seismic sensors, satellite imagery, and ground deformation measurements help predict volcanic behavior, aiming to provide residents with as much notice as possible to evacuate. But, as with any prediction system, there are limits to their accuracy. What happens when systems fail? For example, in 1986, the eruption of Nevado del Ruiz in Colombia was predicted, yet the warnings were mismanaged, resulting in a catastrophic mudflow that killed over 23,000 people. The effectiveness of early warning systems relies not only on technology but on the cooperation and trust between scientists and the communities they aim to protect. The human element cannot be overlooked when discussing risk and response. So as we consider the people living in the volcanic shadows, we must ask ourselves, what sacrifices are communities willing to make, and what protections must society put in place to ensure their safety? The answer to these questions will shape our understanding of coexistence with nature's most powerful forces. As we conclude this chapter, we see the resilience of communities and the pressing need for effective communication and strategies. The shadows of volcanoes loom large, but the spirit of the people living beneath them is stronger still. How can we ensure their stories do not end in tragedy? Volcanic eruptions are not just local events. They send ripples through our environment, impacting air quality, climate, and ecosystems globally. When Mount Tambora erupted in 1815, it triggered what is often referred to as the year without a summer. The ash and sulfur dioxide released into the atmosphere led to significant global cooling, disrupting weather patterns and leading to widespread crop failures. This unprecedented climatic shift resulted in famine across North America and Europe, demonstrating how one eruption can influence food supply on a global scale. Fast forward to more recent history, and we see similar patterns emerging. The 1991 eruption of Mount Pinatubo released about 20 million tons of sulfur dioxide into the stratosphere. The aerosols created from this event caused a decrease in global temperatures by approximately 0.5 degrees Celsius for about 2 years. Such alterations in climate can create domino effects, disrupting marine life, changing precipitation patterns, and pushing vulnerable ecosystems beyond their limits. And it doesn't stop there. Volcanic ash fallout can smother farmland and water sources, leading to soil degradation and loss of habitat. Ash, rich in minerals, might initially benefit the soil, promoting short-term agricultural boosts. However, prolonged exposure can lead to long-term detrimental effects, such as nutrient leaching and altered pH levels. In Iceland, for example, the 2010 eruption of Eyjafjallajökull caused significant agricultural losses not just in Iceland but across Europe due to ash contaminating crops and air travel halting production chains. We must also consider the carbon footprint of volcanic eruptions. While they are often viewed as natural events with limited long-term impacts, they can significantly contribute to our planet's greenhouse gases in the immediate aftermath. For instance, although volcanic eruptions release less carbon dioxide on an annual basis compared to human activities, the sheer volume during a significant eruption can temporarily skew our atmospheric composition, an important factor to consider in climate models. Ecosystems are also at risk. The release of volcanic gases like sulfur dioxide can lead to acid rain, which devastates aquatic ecosystems. Fish populations, amphibians, and plant life can suffer tremendously, leading to cascading effects throughout the food web. This is compounded by the fact that many species are already stressed by human activities and climate change. Adding a volcanic eruption into the mix can tip entire ecosystems into chaos. Moreover, the potential for volcanic eruptions to interact with climate change is a growing area of research. Some scientists are examining how warming temperatures might influence volcanic activity, raising alarms about how interconnected our systems are. The real question is, are we prepared to face the combined challenges of human-induced climate change and natural volcanic activity? The relationship between human activity and volcanic eruptions also poses ethical questions. The communities that bear the brunt of volcanic consequences often contribute the least to global issues like climate change. This inequity raises important discussions about climate justice and global responsibility. Who is accountable for assisting those affected when nature strikes? As we conclude this chapter on environmental consequences, we are reminded that the impact of volcanoes does not respect borders or communities. Eruptions can catalyze worldwide ramifications, and understanding this interconnectedness is crucial as we forge a path for our future interactions with nature. As we move forward, we must consider how we can mitigate these effects, both locally and globally. What steps can we take to prepare for massive upheavals that might sweep across our fragile ecosystems next? Among the most terrifying expressions of volcanic activity lie supereruptions, massive, calamitous eruptions with the power to change the global landscape. A supereruption can expel more than 1,000 cubic kilometers of material in a single event. To put that in perspective, that's enough ash and debris to cover the entire state of Delaware to a depth of more than 2,000 feet. One of the most infamous supereruptions occurred at Yellowstone National Park approximately 640,000 years ago. The eruption produced ash that scattered as far as the east coast of the United States, blanketing much of North America and drastically affecting climate. Estimates suggest that this eruption led to the extinction of numerous species, and it took the environment thousands of years to recover fully. If Yellowstone were to erupt again, its effects would be catastrophic, destroying ecosystems, impacting agriculture, and creating a volcanic winter. Scientists warn that the warming planet may increase the chances of a supereruption, as increased tectonic activity could coincide with melting glaciers. Notably, the Toba supereruption in Indonesia around 74,000 years ago is thought to have nearly eradicated human life on the planet. The volcanic winter that followed drastically reduced temperatures and caused significant disruptions in the food supply, leading to what some researchers believe was a near-extinction event in early human populations. A fascinating study suggests that the explosion might have shrunk the human population to as few as 15,000 individuals. The genetic bottleneck from this period has left an indelible mark on humanity's genetic diversity. But why do supereruptions occur? They result from massive magma accumulation beneath a volcano. Pressurized gases and molten rock build up until an explosive eruption is inevitable. Scientists have attempted to predict these events, but the complexities of geology make it exceptionally challenging. Monitoring techniques have improved, but many of the signs leading up to a supereruption can be subtle or misleading. Currently, researchers are utilizing advanced technologies, such as remote sensing and high-resolution satellite imagery, to detect changes in volcanic behavior. But the reality remains stark. Predicting an eruption of such magnitude is still fraught with uncertainty. The question arises, how can we safeguard humanity against an event that may occur with little warning? In addition to prediction, discussion around preparedness is vital. For a supereruption, there would be no simple evacuation plan. Major cities could face ash fallout, air travel could be grounded, and food supplies could plummet. Governments globally would face unprecedented challenges in responding to such an event. A collaborative, international approach to managing the potential fallout could mean the difference between life and death. Another concern arises in the aftermath of supereruptions. How would we manage resources? The infrastructure of modern societies, already strained by population growth and climate change, could break under the stress of a supereruption. The food supply chain could collapse, particularly with industries like agriculture facing immediate threats. This feeds into a larger discourse regarding resiliency and sustainability in our current systems. Are we truly prepared for such an existential risk? As we conclude this chapter on supereruptions, we are reminded of the profound power of nature and the fragile thread of human existence. Supervolcanoes stand as a reminder of our vulnerability, not just as individuals, but as a civilization, reminding us of the interconnectedness of life, land, and the natural forces that govern our world. The reality of a supereruption brings us face to face with a question we must grapple with: how can we collectively prepare for something as profound as the end of our civilization? As we traverse through our exploration of volcanoes, one undeniable truth emerges: understanding and monitoring these geological giants is critical to minimizing risks and safeguarding our future. The future of volcano monitoring is not merely a scientific endeavor, it's a lifeline for communities at risk. Innovations in technology are transforming the way scientists study volcanic activity. Seismic monitoring, once limited to ground stations, now incorporates satellite imagery and drones equipped with thermal sensors, allowing researchers to capture real-time data from even the most dangerous sites. These advancements offer unprecedented insights into volcanic behavior, enabling scientists to detect changes that could signal an impending eruption. Moreover, machine learning and artificial intelligence are beginning to play a pivotal role in data analysis. By processing vast amounts of seismic gas and thermal data from volcanoes worldwide, these technologies can help identify patterns and trends that human analysts may overlook. Early warning systems could see a significant upgrade, potentially leading to more accurate predictions and timely evacuations. Yet, with all these advancements come challenges. The funding for volcanic research is often limited, and many monitoring stations are located in remote areas, making maintenance difficult. Countries like the United States and Italy have established robust monitoring networks, but many developing nations, where volcanic threats loom large, lack the resources necessary for comprehensive monitoring. This raises important questions about equity in disaster preparedness. How can we ensure that all communities, regardless of location or income, have access to vital monitoring technologies? Public engagement in monitoring efforts is also a growing trend. Citizen scientists are increasingly being recruited to help monitor volcanic activity. Through mobile apps and online platforms, individuals living near volcanoes can contribute valuable observations, turning local knowledge into scientific data. This collaboration can fortify the existing monitoring systems and foster a sense of community resilience. Moreover, educational initiatives play a crucial role in fostering a culture of preparedness. Teaching communities about volcanic behavior, emergency plans, and evacuation routes can drastically improve response times during a crisis. This empowerment is key in reducing panic and ensuring that people know how to respond when the ground starts to shake. As we look ahead, the integration of interdisciplinary approaches will be vital. Collaboration between geologists, climatologists, urban planners, and policymakers will foster more holistic strategies for risk management. We need to prepare not only for eruptions but also for the ripple effects they may cause across multiple sectors: economics, health, and the environment. Ultimately, the future of volcano monitoring hinges on our ability to adapt and innovate. As technology evolves and our understanding of volcanic systems deepens, we must remain vigilant and dedicated to reducing risks. The stakes are high, but with collaboration and commitment, we can enhance our preparedness and resilience. As we conclude this chapter, the vision for volcano monitoring transcends just technology. It encapsulates our collective responsibility to safeguard lives and protect the planet. What will we choose to do with the knowledge we've gained? The answer lies in how we build our future, adapting our approach to the challenges that lie ahead. As we reach the final chapter of our documentary, we take a moment to reflect on the resilience of humanity in the face of nature's formidable forces. Throughout history, we have witnessed how volcanic eruptions have shaped societies, cultures, and the environment. Each eruption not only leaves behind ash and destruction but also teaches us vital lessons about our existence and interconnectedness. Volcanoes, while dangerous, have been integral to human development. The fertile lands around them have sustained agriculture for centuries, and the minerals they provide have enabled countless innovations. They are reminders of life's duality, beauty intertwined with peril. The history of human adaptation to volcanic threats is one of ingenuity and perseverance. In the 1980s, the residents around Mount St. Helens constructed shelters and evacuation plans in response to the volcano's awakening. This proactive mindset significantly reduced casualties during its eruption in 1980. Such actions illustrate that, while the threat is real, the response can be just as powerful, emphasizing the critical need for preparation and education. As we consider the future, we must hold on to the belief that knowledge and resilience will guide us. Climate change, urbanization, and population growth add layers of complexity to our relationship with volcanoes. Nevertheless, communities continue to showcase extraordinary resilience. For instance, in recent years, the island of La Réunion has embraced a unique approach to education, blending cultural traditions with modern science to teach residents about the dangers posed by Piton de la Fournaise, a volcano that has erupted regularly since the 18th century. Globally, there's an emerging movement advocating for the recognition of indigenous knowledge in disaster preparedness. Indigenous communities often possess intimate understanding and deep connections to their environments, offering unique insights into sustainable practices and potential responses to volcanic threats. This integration can lead to a more comprehensive approach to resilience, drawing from both scientific advancements and traditional wisdom. However, resilience is not without its challenges. The voice of marginalized or vulnerable populations must be amplified in discussions about disaster preparedness. Often, these communities face disproportionate risks yet remain underrepresented in conversations about response strategies. Encouraging inclusive dialogue can ensure that all perspectives are considered, improving overall community preparedness. As we conclude our journey, let us remember that the story of volcanoes is not merely one of destruction but of survival, adaptation, and hope. How we choose to respond to these geological giants will shape our future. The essence of humanity is to rise, to learn from adversity, and to strive for a more resilient future. In the end, the question arises, what legacy will we leave for future generations? The challenges posed by volcanoes are real, but so are our capacities for compassion, innovation, and collaboration. As we continue to navigate this complex world, let us carry forward the lessons of the past while bravely facing the uncertainties of tomorrow. With the potential for extinction looming behind every eruption, it is our response, the strength of our communities, our determination to learn and adapt, and our commitment to each other that will define us. Together, we can emerge as a resilient civilization, ready to meet whatever challenges lie ahead. Volcanoes have played a significant role in shaping human civilization throughout history. They have provided fertile soil for agriculture, which has allowed societies to thrive. For instance, the volcanic soils of the Fertile Crescent are believed to have contributed to the rise of some of the earliest civilizations in Mesopotamia. These soils, rich in nutrients from volcanic ash, supported the growth of crops that fed entire populations. But, as beneficial as they can be, volcanoes also bring with them catastrophic potential. This juxtaposition creates a complex relationship between humanity and nature, one that has evolved over thousands of years. In ancient Rome, for example, the eruption of Mount Vesuvius in 79 AD buried the city of Pompeii under a thick blanket of ash, preserving it for centuries. Archaeologists have uncovered remarkable insights into Roman life through the ruins of this city, yet the eruption was a devastating event that claimed thousands of lives. The cultural impacts of volcanic eruptions are profound. In Hawaiian mythology, Pele, the goddess of fire and volcanoes, represents both destruction and creation. The lava flows provide new land and the minerals necessary for life, yet they can also obliterate entire communities. This duality highlights the awe and fear that volcanoes invoke in human societies. Various cultures have different interpretations of volcanic activity. In Indonesia, the eruption of Krakatoa in 1883 led to monumental changes in weather patterns worldwide and affected global temperatures. The ash released into the stratosphere caused spectacular sunsets and cooler temperatures for years to come. The eruption was so powerful that the sound was heard over 3,000 miles away, marking it as one of the loudest events in recorded history. Throughout history, volcanic activity has led to migrations. The eruption of Mount Taamu Massif around 145 million years ago released enormous quantities of lava, reshaping the region and affecting species and their habitats. These geological changes can force human populations to relocate, reshaping the fabric of societies. Contemporary societies have learned from historical eruptions and are better equipped to handle potential threats. However, the integration of volcanic studies into urban planning is still a crucial challenge. For example, Naples sits at the base of Vesuvius, with millions of people living in its shadow. As we advance our understanding, we must reconcile the allure of living among these natural wonders with the risks they pose. The relationship between humanity and volcanoes is not merely one of survival against elemental forces, it is a tale of symbiosis, conflict, and adaptation. From the ashes of destruction arise stories of resilience and triumph, forming a narrative that stretches back to the dawn of civilization. Yet, as we look to the future, we must remain vigilant and respect the forces of nature that shape our world, understanding that not all eruptions lead to devastation. some, in their aftermath, could even lead to new beginnings for humanity. As we explore what civilization might look like after a catastrophic eruption, we must acknowledge that history teaches us valuable lessons. Through cooperation, understanding, and preparedness, we can harness the knowledge of our ancestors to mitigate risks and cultivate resilience. The stories of our past can guide us as we navigate the challenges that volcanoes present. What lies ahead may not only be a battle against geological forces but a fulfillment of our collective responsibility towards our planet and our future generations. Living in the shadow of a volcano can evoke complex psychological responses. On one hand, there is a sense of awe, a feeling of being connected to something immense and powerful. People often describe living near volcanoes as exhilarating, with the constant reminder of nature's grandeur. However, this admiration can be intertwined with fear and anxiety about potential eruptions. Studies show that the psychological impact of living near volcanoes can be profound. Residents in regions like the Indonesian island of Sumatra, near Mount Sinabung, have faced multiple evacuations due to volcanic activity. The uncertainty and anxiety stemming from these events can lead to heightened stress levels in communities. A 2014 study published in the International Journal of Disaster Risk Reduction highlighted significant mental health challenges faced by residents living near active volcanoes. Individuals report symptoms of post-traumatic stress disorder, PTSD, after experiencing an eruption or even just living with the threat of one. Conversely, there is a phenomenon known as volcanic attraction, the allure of living close to these natural wonders. The landscape, often lush and beautiful due to volcanic soil, draws people for its beauty and cultural significance. Many residents foster a deep attachment to their home, viewing the volcano almost as a guardian rather than a threat. This duality creates a psychological tension, where people must reconcile their fear of eruption with their love for the land. The Kilauea eruption in Hawaii serves as a significant case study in the psychology of living with volcanoes. When Kilauea erupted in 2018, many residents were forced to evacuate, leaving behind homes and belongings. The emotional toll of such displacement is immense. Psychologists noted that many residents felt a profound sense of loss and grief, not just for their homes, but for their communities, which were transformed by the eruption. This experience of losing one's home ties into deeper human emotions surrounding safety, belonging, and identity. Community dynamics also play a role in living near volcanoes. Social support systems are critical in helping individuals cope with the psychological impacts of volcanic activity. In the aftermath of eruptions, communities often come together, sharing resources and emotional support. These acts of solidarity can foster resilience and promote healing, helping individuals navigate the challenges posed by living near an active volcano. However, the psychological impacts do not only affect adults. Children living in volcanic regions are particularly vulnerable. They may not fully comprehend the risks involved, leading to fears that can manifest in behavioral issues or anxiety disorders. Educational programs that teach children about volcanoes and safety can help alleviate some of these fears. Engaging with youth about the science behind eruptions allows them to feel empowered rather than endangered. Moreover, efforts to integrate mental health support services into disaster preparedness plans can make a significant difference. By addressing psychological needs alongside physical safety, communities can cultivate a holistic approach to resilience. Studies have shown that communities prepared to deal with psychological stress are better able to recover after an eruption. Living in the shadow of a volcano is a delicate balance of respect, fear, and admiration. While the threat of destruction looms, so too does the potential for beauty, community, and connection to the land. As we continue to explore the psychology of these regions, we unearth not only the challenges they face but also the enduring strength of the human spirit. Future research will help us deepen our understanding of this relationship, paving the way for improved mental health support for those who navigate this extraordinary landscape. Ultimately, the story of living near volcanoes is one of resilience in the face of unpredictability, and it brings to light the incredible capacity for humans to adapt and thrive against the odds. History is replete with volcanic eruptions that have left indelible marks on civilization. These events provide crucial lessons on preparedness, response, and the long-term impact of volcanic activity. By examining historical eruptions, we can better understand the dynamics of volcanic threats and how they have shaped human societies. One of the most infamous eruptions in history is the 1783 eruption of Loki in Iceland. Spewing ashen gases into the atmosphere, this eruption caused massive fatalities, not only in Iceland but across Europe. It is estimated that around 25% of the Icelandic population perished due to respiratory issues, starvation, and the ensuing harsh climate changes. The sulfur dioxide released contributed to what became known as the mist of death, as it poisoned crops and provoked famine. This eruption serves as a stark reminder of the far-reaching consequences of volcanic activity, showing that eruptions can have global effects, altering weather patterns and agricultural yields far from their epicenter. In contrast, the eruption of Mount St. Helens in 1980 provides an example of effective monitoring and preparedness. Forewarnings from scientists allowed for timely evacuations, minimizing loss of life. The U.S. Geological Survey's response and the communication with local communities exemplify the importance of proactive measures in safeguarding lives. The eruption resulted in significant property damage and ecological change, yet because of the monitoring efforts, only 57 lives were lost. This stands in stark contrast to historical eruptions where communities were caught unprepared. The case of the eruption of Mount Pinatubo in 1991 also offers valuable lessons. After monitoring its seismic activity, scientists were able to provide early warnings that led to evacuations of thousands of people. This eruption had a profound impact on global climate, with ash injected high into the atmosphere that cooled temperatures worldwide. The eruption caused widespread devastation in the Philippines but demonstrated the significance of accurate predictions and global responses to volcanic threats. These examples underscore the need for continuous research, public awareness campaigns, and community preparedness training. Governments must prioritize investing in monitoring technologies and creating plans that include evacuation routes, communication strategies, and education programs for at-risk populations. The lessons from the past can ensure that communities are better prepared for the future. On a microscale, examining the 1991 eruption of Unzen in Japan reveals how local cultures adapt to volcanic risks. The long history of volcanic activity in Japan has fostered a culture of awareness and respect for nature. Communities have developed an intricate understanding of their environment, which aids in their ability to respond and rebuild following eruptions. This cultural adaptation can directly influence resilience and recovery times after volcanic events. In looking towards the future, the integration of science and community response efforts is crucial. Combining empirical data with the lived experiences of communities can create a comprehensive approach to volcanic risk management. Historical case studies remind us that preparation is vital, and as we face the ongoing threat of potential supereruptions, we must commit to understanding and mitigating the risks these geological giants pose. The lessons learned from these historical eruptions resonate through time, serving as a compass for how we might navigate the challenges of the future. Our relationship with these natural wonders is complex, and as we move forward, embracing both scientific advancements and community wisdom will be essential in ensuring the survival of humanity amidst the ever-present threat of volcanic calamity. In an age where technology seems to touch every aspect of our lives, it's no surprise that it's also revolutionizing how we understand and monitor volcanic activity. Imagine a world where we can predict eruptions with pinpoint accuracy, where technology saves lives by providing timely warnings to communities at risk. The integration of satellites, drones, and advanced sensors has made significant strides in volcanic research. Satellites orbiting our planet can detect subtle changes in land deformation, an indication that magma is moving beneath the surface. This technology, known as INSAR, or Interferometric Synthetic Aperture Radar, allows scientists to create detailed topographic maps that show how the ground shifts over time. A perfect example is the 2014 eruption of Holuhraun in Iceland. Scientists used satellite data to observe ground deformation patterns that preceded the eruption, allowing for more accurate forecasting. But it's not just satellites. Drones equipped with thermal imaging cameras can fly directly over volcanoes to capture real-time data. Researchers can measure gas emissions, temperature changes, and even collect samples from hard-to-reach areas. One such drone mission occurred during the 2018 eruption of Kilauea in Hawaii, where researchers used aerial surveys to assess lava flow and gas emissions, helping to inform both response efforts and scientific understanding. Additionally, ground-based sensors like seismographs and GPS stations have become essential tools. These instruments measure tremors, ground movement, and volcanic gases, offering critical data to predict eruptions. Consider Mount St. Helens, where a network of seismic monitors provided crucial alerts before its catastrophic eruption in 1980. As a result, scientists developed better predictive models that are still in use today. Despite these technological advancements, challenges remain in volcano monitoring. The unpredictable nature of volcanoes means that no amount of technology can guarantee safety. For example, in 1991, Mount Pinatubo erupted in the Philippines after years of dormancy, catching many scientists off guard despite monitoring efforts. This serves as a reminder that while technology enhances our understanding, it cannot wholly eliminate the risks associated with volcanic activity. As we look to the future, the synergy between traditional monitoring methods and cutting-edge technology holds promise. Researchers are pushing the boundaries of what's possible, exploring AI algorithms to analyze vast datasets and predict volcanic behavior. This evolution in monitoring will not only protect lives but also provide invaluable insights into the workings of our planet. With each technological leap, we inch closer to a world where we can coexist with these magnificent yet threatening giants, understanding their language better than ever before. In the next chapter, we will explore the fascinating interactions between volcanic activity and climate change, how these earth-shaping forces are more connected than we may realize. Volcanoes and climate change may seem like two disparate topics, but they are intricately linked in ways that can shape our planet's future. When we think about climate change, we often focus on human activities, emissions from cars, factories, and deforestation. Yet, volcanoes can also have a dramatic impact on global climate. The most notable example of this connection is the eruption of Mount Pinatubo in 1991, which released an enormous amount of ash and sulfur dioxide into the stratosphere. This led to a temporary cooling of the Earth's surface, with global temperatures dropping by about 0.5 degrees Celsius over the following years. The ash from the eruption created a veil that reflected sunlight away from the planet, demonstrating how volcanic eruptions can influence climate patterns. But what does this mean for our future? As the planet heats up due to human-induced climate change, there's potential for increased volcanic activity, not solely from melting glaciers reducing pressure on magma chambers but also from the geological instability that comes with climate fluctuations. Recent studies suggest that as the Earth's surface temperature rises, it could prompt dormant volcanoes to awaken, thereby introducing a feedback loop where eruptions further impact climate. Consider the case of the Icelandic volcano Surtsey, which erupted during the 1960s. There, scientists observed the correlation between volcanic activity and changing ocean temperatures, each shift creating a ripple effect that impacted the entire ecosystem. This exemplifies the need for interdisciplinary research that crosses the boundaries of geology and climate science. Furthermore, the ash and gases expelled during eruptions can have long-term consequences for agriculture. While some volcanic ash can provide fertile soil, excessive amounts can contaminate water supplies and affect crop yields, particularly in areas already threatened by climate change. In the aftermath of the 2010 eruption of Eyjafjallajökull in Iceland, farmers faced significant challenges as ash blanketed their fields, disrupting the delicate balance of food production. In light of this, it's essential to foster a better understanding of how we can prepare for and mitigate the effects of both climate change and volcanic activity. Can enhanced monitoring systems help us predict where volcanic eruptions may coincide with climate-related disasters? The answer lies in a more collaborative approach. Scientists from various fields must join forces to address this issue holistically. By examining the connection between volcanoes and climate change, we not only gain insight into our planet's behavior but also hone our strategies for survival. As we unveil more connections, we realize that these forces of nature are not isolated. They are part of a vast web of interactions that influence our very existence. Yet amidst these challenges, the question remains, are we prepared for the upheavals that lie ahead? In the final chapter, we'll explore the resilient spirit of humanity in the face of natural disasters and how we can learn from the past to build a safer future. As we confront the ongoing threats posed by volcanoes, humanity's resilience and innovative spirit shine as beacons of hope. Throughout history, people have learned to adapt to the dangers of living near volcanoes, using creativity and resourcefulness to forge a path forward. Cities like Naples in Italy exist in the shadow of Mount Vesuvius, a volcano that has erupted multiple times throughout history, including the catastrophic eruption that buried Pompeii in 79 AD. Yet, despite this threat, Naples thrives. How? Through a combination of community preparedness, education, and architectural adaptations. Residents participate in evacuation drills and are educated about the risks, ensuring that in the event of an emergency, they can swiftly respond. Innovative architectural designs also mitigate volcanic impact. Buildings constructed with flexible materials can withstand tremors, while strategically placed shelters provide refuge in emergencies. Further, the use of technology in monitoring and early warning systems is evolving rapidly. For example, Japan has implemented intricate warning systems that notify residents within minutes of seismic activity, providing audible alerts and text message warnings. Such systems can save countless lives by giving residents time to react before disaster strikes. In addition to technology, community resilience plays a crucial role. The community in the town of Pahoa on Hawaii's Big Island has exemplified how a united front can lead to innovative solutions. During the 2014 eruption of Kilauea, locals banded together to create outreach programs that educated residents about volcanic hazards, evacuation routes, and individual preparedness. This community-centered approach not only enhances safety but fosters a sense of belonging and shared purpose. As we pivot our gaze to developing nations, the story is less rosy. Countries such as Indonesia and the Philippines face significant challenges with volcanic threats coupled with poverty and limited resources. Yet even there, stories of resilience emerge. In 2018, as Mount Sinabung erupted, local disaster response agencies worked tirelessly to evacuate thousands and provide aid to those affected, demonstrating that even in the face of adversity, innovation and human spirit can prevail. In this light, we see strategic innovations, like the implementation of mobile apps for real-time updates on volcanic activity, becoming lifelines for people living in danger zones. These technologies empower individuals to stay informed and make crucial decisions that could save their lives. As we contemplate the future, the resilience of humanity in the face of nature's fury becomes even more evident. The lessons learned from past eruptions compel us to continue innovating, developing better monitoring technologies, enhancing building practices, and creating support systems for affected communities. The strength lies not only in our ability to withstand volcanic challenges but also in our capacity to adapt and rise above them. As we wrap up our exploration of volcanoes and their impact on civilization, one thing is clear: nature is powerful, but so too is the human spirit. Will our ingenuity be enough to prepare for future eruptions? Only time will tell, but one thing's for sure: the lessons of the past will light the path forward. As long as humans have walked the earth, volcanoes have captured our imagination, inspiring countless myths and legends. These fiery mountains have been depicted as God's wrath, gateways to the underworld, or even harbingers of doom. From the ancient Romans to indigenous cultures worldwide, the fear and respect for these geological phenomena have manifested in intriguing ways. Volcanoes have been woven into the fabric of our stories, influencing religion, art, and even politics. The Romans, for instance, revered the volcano Mount Vesuvius not only as a natural wonder but as a deity of destruction. When Vesuvius erupted in 79 AD, burying the city of Pompeii, it was seen as divine retribution. The archaeological findings from Pompeii reveal not just the power of the eruption but also how deeply entrenched the fear of such natural disasters was in their society. Similar themes appear in the myths of the ancient Greeks, where Mount Etna was believed to be the forge of Hephaestus, the god of fire and blacksmiths. The myths served as a way to understand and cope with the terrifying power of volcanoes. Furthermore, these stories have impacted various cultures' settlement patterns, influencing where people choose to live, often dangerously close to these potential threats. Today, scientists study the geological history of these volcanoes to piece together their past eruptions and predict their future behavior. As technology advances, we're gaining a clearer understanding of these hidden giants, but the myths still linger, shaping our perception and response to volcanoes. As we unravel the truth behind the myths, we realize that while volcanoes can be catastrophic, they also play a crucial role in Earth's geology and ecosystems. The very soil enriched by volcanic ash supports agriculture in various regions, sustaining communities. This duality of destruction and creation reflects the complex relationship humans have with these mighty forces. In this chapter, we've explored how humanity's tales about volcanoes connect us to nature's wrath and beauty. As we move forward, we must recognize that these narratives serve not only as cautionary tales but as lessons that have shaped civilization itself. In the face of volcanic threats, education emerges as a crucial tool for empowering communities. Understanding the dangers posed by volcanoes and how to respond can save lives. In this chapter, we delve into the educational initiatives that seek to raise awareness about volcanoes, their behaviors, and the risks associated with them. One notable example is the Volcano Awareness Program in Hawaii, where residents and tourists alike are educated about the behavior of Kilauea, one of the most active volcanoes in the world. This program offers workshops, guided tours, and even online resources to ensure that everyone has access to vital information. Similarly, the Geoscience Australia initiative focuses on volcanology education, providing vital resources to schools and communities